Hello, my name is David Bryan, and this is Curiosity Invited, a podcast inspired by endless curiosity. Tune in for an open-minded conversation about interesting and important things. Well, welcome, everybody. Welcome to Curiosity Invited. My name is David Bryan, and today I have the great pleasure of speaking with Larry Birnbaum. Probably in certain circles, that name is well known, but in others, it may not be. Larry is a computer scientist. Among other things, he's a professor at Northwestern, where he's been a professor there since the late 80s, I believe, 89, I think it was.
That's right, yeah.
As according to something I read. And he was both, and is this still true, Larry? You are both in the computer science or engineering school and journalism?
I think technically that my courtesy appointment in journalism has lapsed, but I actually still teach over there, and I'll be teaching a course with a colleague of mine, Jeremy Gilbert, in the Medill School of Journalism at Northwestern this spring, a joint course with CS students and journalism students in technology and journalism.
That's great. And so you've been doing this a while. And anyway, thank you for being willing to speak to a lay person about something that it's funny. So Larry got his PhD in computer science from Yale in 1986.
Probably that's right.
Something like that. Yeah.
It's a long time. And ancient history anyway.
It's ancient history. And he may be more modest than I'm going to be, but about him, he has been in all sorts of ways at the cutting edge of a corner of computer science for many years, and that corner is on the tips of everybody's tongue these days. Chat GPT and the Microsoft's Tay and the artificial intelligence that is, increasingly either is either seen as the great step forward or something that should keep you all up at night. And Larry's been generous enough to come and put up with people asking stupid questions and not understanding. But I will say this one story. So when I asked if Larry if he would come and speak about that, you said, that's not my area, but I know something about it. And so here's what I want to know. My first question, and I hope this is more a discussion at times than just question answer. But
sure.
So if my car breaks down on the side of the road, and there's it's in the middle of the desert, and nobody comes along for it, and somebody drives by, and I flag him down, and he stops, and I said, "Man, I don't know what's going on. My car's broke." He said, "Well, it's really not my area. I'm a mechanic for drag racers, so I'm not." So is that the way in which this is not your area? From our point of view, this is absolutely your area, but from your point of view, it's not.
Yeah, academics can be pretty narrow sometimes.
Yes, so that's what I got when I was watching.
I think also I think all of us have a desire to make sure that we sort of qualify our statements by how much we think we know about something, and I apologize for that. I mean, it's very typical when you give a talk in an academic setting, for example, that when you ask a question, I mean, you'll because even if you're just in the computer science department, a lot of the talks you see will not be what you do research on and not really be what you're an expert in. I mean, obviously, compared to lay people, I know something about it. I can go to the talk and I can kind of understand the talk.
Right.
And I can even ask questions. But, almost invariably, in those situations, you'll preface what you're saying with, quote, "This may be a naive question, but," or you'll say things like, "This is not really my area, but," and that's a very common thing to do in academics, just because it's kind of a professional courtesy to make it clear that,
yes,
because there are real experts,
Yeah.
So, I mean, just to say, David, a little bit about that. I mean, I've worked in natural language processing, which is getting computers to manipulate or understand or generate natural language for most of my career. But I'm not an expert in machine learning or in large language models, neural language models. I obviously know something about them, and I do research with them and using them, but it hasn't been my area. So it's of specific expertise. And that's the sense in which I wanted to sort of
That-
qualify
and
the whole
that, and
thing.
that and that is exactly what I thought. Especially the more and more I read some of your stuff and looked at and watched lectures, et cetera, to listen to and watched lectures, is like, what's he talking about? This
Yeah,
is
right.
his area.
I understand. I mean, I
Yeah,
think
yeah.
it's partly protection also. You know, if somebody who really is an expert in this area watches me, I want to make sure they know I
I
did the
know.
proper disclaimer.
Yes,
You know what I'm saying?
exactly,
I'm not
exactly.
pretending to know something I don't
Yeah.
actually know. So
Well, so how important at the beginning of this conversation is to define terms? So there's a lot of that thrown around, right? There's AI, there's machine language, there's artificial intelligence, there's deep learning, there's yada yada, there's
yep,
NLP, NLG,
yep,
whatever.
yep.
So so um is it are there differences between some of those things, a little and a lot? Or is it under one umbrella called, I mean, obviously it's all called computer science, but is AI deeply different from machine learning, different from deep learning? And how important is it to understand those things for us
Right.
to understand anything you're going to say?
Right, right. So the first thing to say is that AI, artificial intelligence, is actually itself a pretty broad field
Yes.
with a lot of different kinds of technologies and a lot of different kinds of problems. I mean, there's people who work on computer vision. I know hardly anything about computer vision. I mean, a little bit. Again,
You mean
it's
computer vision, meaning
yeah, getting
recognition by
computers
camera?
to
Yeah.
absolutely.
Yeah.
There's audio analysis, there's speech recognition, there's natural language processing, there's machine learning, there's deep learning, which is a kind of machine learning.
Right.
It's there's uh, theorem proving and logic. There's planning. There's graph algorithms. I mean, there's just a tremendous amount of stuff that goes on under the hood in any one of these systems. And there was a famous uh, uh, idea very early on in AI that the minute we understand a problem, it's no longer AI because it just becomes another computer program. So
Right.
it doesn't seem mysterious anymore. It's just another. So of course there was a time, for example, when route planning, the kind of thing that Google Maps does for you, or Siri, or any of those
Hmm.
commercial systems, that was an AI problem. I mean, doing route planning and figuring out, given a graph, how to get from A to B would have been considered an AI problem. I mean,
Mhm.
and it still actually takes a certain kind of AI technology, and we still teach that stuff, to people in AI. It's just that it's kind of become ubiquitous and no longer considered. It's not a research area so much anymore. Perhaps is another way of
Right.
putting it. It's a mostly, although not completely, solved problem. Yeah.
Well, so does it make sense for you to talk a little bit about, this is genuinely a question. Does it make sense for you to talk a little bit about the research that you did? I know you were one of the founders of a company called Narrative Science, which
Right.
is, I think it was sold to Tableau and then to Salesforce
Right.
and 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 where is that now? Are you still involved with that?
Yeah, I am actually. I still work. I'm a advisor to Salesforce. I don't work for them full time. I
Got it.
work for Northwestern University. But
Sure.
yeah, narrative science was maybe one of the first companies aimed at generating natural language narratives or stories from data. So the idea uh, was the premise was basically this. As more and more data are being gathered, of course, data science and data analytics have become more and more important as a basis of decision making, of human decision making. I mean, more of these decisions are being data driven all the time because we have more data.
Hmm.
And there's this kind of last mile problem, which is you have some data analyst who sets up some system, and they have computed some numbers for you, and now you have to convey that information to a human being who's a decision maker, who's going to actually, and that might be you as an individual who's deciding what to do with your finances or with your
Right.
health, or it might
Right.
be a company trying to figure out what to do in terms of market analysis or segmentation or something like that, and or production problems or processes. And so this last mile problem is how to convey the results of the analytics to people in a way that they can understand so that they can actually take coherent action on it. And that turned out to be quite a challenge. So data visualization, which you may know of, that's the automatic generation of charts and graphs from data, and they're all over the place now. Of
Right.
course, they don't have to
Right.
be created by hand anymore. There's systems to do that. So, for example, Tableau is maybe the premier software platform for generating charts and graphs from data. Tableau was acquired by Salesforce a couple of years ago, which is how the Salesforce connection happens. We took a different point of view, which was rather than trying to present the information to people in terms of charts and graphs, maybe we would present the information to people in terms of natural language narratives. And we started with sports stories, actually, with baseball game recaps. So we would take the data from a baseball game, the line score, the box score, and the play-by-play data, and we would actually generate a sort of something that approximated the AP short recap, which is a story that's usually written within an hour after a baseball game ends. And it did a pretty credible job. We actually got a system that could do quite a nice job of that kind of thing. And that's when we started the company Narrative Science. That original technology was developed at Northwestern University and by me and my colleagues and some students. And we loved it. I mean, it was great, actually. And just to be clear about this, there's no point in doing this for professional sports because there's plenty of money in professional sports to hire a human being to write that story. Do you know what I'm saying? Where it becomes important is in things like youth sports, like Little League.
Yes.
You can't afford to assign a reporter to every Little League game or every high school football game or something like that. It's impossible, right? So it costs too much money to actually do that. So if you can get those data, and there are organizations, for example, there's a company called Game Changer, which has a smartphone scoring app, and if a coach or a parent uploads the data from a Little League baseball game, we can write a story based on those data and actually give it, and who reads that story? I don't know, 3 people, 5 people, 10 people.
Certainly everybody on the team.
The kids on the team and their
Sure.
and their happy parents and grandparents and friends. I mean,
absolutely. You're in the paper.
So that's exactly right. So that's kind of the so I guess the main point to say there is that it becomes important to do this by machine when you need to do it at scale. When you need to do it, in other words, if you need to write 10 stories, hire a person to write 10 stories, even 100 stories.
Right.
When you need to write 10,000 or 10 million stories, then you actually need a machine. And then the question is, when do you need to write that many stories? And the answer is when it's personalized, when it's a story for you about things that matter to you and nobody else. Right. Then, because then we have to write the story for you based on your concerns and the data that are relevant to you. And that's when automation and AI matter, really. Yeah.
And in one of your lectures, I just thought it was a great example of, it was a particular store, and I don't remember if it was a deli or a food store or an auto parts store or something. And to have the specific, because it's in the data, but it's probably not in the data in a way that anybody who's working in the store is going to understand how to use it. But this, to learn that, that was it. There was a Reuben sandwich, right? To learn that the Reuben sandwiches in your store were not selling nearly as much as in that store, at the next town over, which, that's tedious and stupid from most people's point of view. But for people working in that store and certainly managing that store, that's crucial. And how do you get that information? Yeah. The idea that there's a program or that there's programs that can extract that information and give meaningful, useful information is really, phenomenal, really.
Yeah, thank you. I mean, that's that. Of course, let's be clear that prototype was not built for a restaurant franchise that sold Reuben sandwiches.
Yes,
that was to protect the innocent, or the name of the organization that actually does do that. But yeah, so for example, fast food franchises, the managers of those stores have access to a tremendous amount of data, but they're very busy people. They're incredibly competent people, but they don't necessarily, have degrees they don't necessarily have MBAs or degrees in data analytics or something like that. And so taking those data and distilling them into a form that is meaningful to them and giving them something that's actionable, and what I think what the line that probably stuck with you is when I talk about that story, I say, this is the world's most boring story unless you happen to be the manager of this restaurant, in which case it's an extremely interesting story.
This is the most interesting story you've gotten all year.
It's interesting to you because it matters to you, right? So, it's funny when we were doing the baseball game stuff. The baseball game recaps have a pretty set structure, which is you typically have to talk at the beginning about who won the game, and the basic reason why they won the game, what happened. And here we have kind of analytics that are about things like the shape of the game, and what I mean by that is, was this a defensive struggle? Was it a blowout? Was it a come from behind victory? Was it due to one very strong player, or was it a team effort, and so on? And you can
Mhm.
see the patterns of the stuff in the data and give voice to that in the story about who won and why they won based on these kinds of things. And then you have to talk about pitching, because in a baseball game story, the pitching is very critical. So you then talk about the pitching. And then after that, you have to talk about the other significant things that happened in the game. For example, if somebody, got a lot of, got on base a lot, um, you have to mention that even if it wasn't really relevant to the outcome of the game.
Mhm.
So, because it's a significant event in baseball. And so there's a bunch of other stuff down there, organized either temporally in terms of the inning that it happened in, or by the player. We had, when we first did this, we had a budding sports journalist on our team, and we asked him, so what's the format? And it turned out there was a format. It's the one I just gave you, but it was actually hard to pull it out of him. This is a very common uh,
Right.
a
Right.
common experience of people working in AI and other kinds of sort of disciplines involved with experts, which is people know a lot and they don't know what they know,
Yes.
and you have to actually kind of pull it out of them, kind of forcefully, to actually get them to enunciate it. Anyway, at one point I thought, hey, you know what? We could actually rewrite this to have a kind of a cliffhanger thing. There's a kind of a hackneyed thing you could do, and you see this sometimes in television scripts, for example, where the opening scene will be some confrontation or something, and that turns out to be the middle of the story, and then it backs up to the beginning of the story, like, how
Yes.
did we get here?
Right.
And then eventually, about the middle of the show, you finally get there, and then you go on from there. And I thought we could do that. We could have a sort of a baseball game story that went, hey, it's late in
Right.
the game, and
Yeah,
they're
exactly.
down by two, and it's the 2 outs, and Mighty Casey is at the bat, and dot dot dot. How did we get here? And then kind of as a way of building tension.
Sure.
That's a kind of
It's,
hacking way
it's,
of
I
building
mean, in all
tension.
sorts of ways, like sort of better writing. I mean, better TV shows, better writing, better, you don't.
Yeah. So we showed this to the journal, the guy on our team who was the budding sports journalist, and he said, "This is a terrible story. This is a story for people who don't like baseball." And I thought, like, yeah, that's right. It's not the way, because the people
Yeah.
who read baseball game stories, they're not interested in artificial methods for jacking up the tension. They care inherently,
Yeah.
They don't.
Well, I
Anyway,
think
so
actually it's also it's a terrible story also because in the old days, and probably the way people are trained in many journalism programs, it's like, you write. I remember doing this when I was, years back. It was like you write so that the editor can carve things off from the bottom of the story because they have to fit in this amount of
mhm.
space. And so, you give all the information that you really need to give at the beginning so that if it, you just keep cutting.
Yeah,
And
it's the so-called inverted pyramid model. That's
yeah,
correct.
yeah,
Yeah.
exactly. So it's just what a terrible story, but it's much better.
Actually, this is a sort of, I think this is true, but it might not be true. But of course, there's an implication of the inverted pyramid model for news stories, which is that if you want to index a news story in a search engine, it's the stuff at the top of the story that's most important. You know,
Yes.
as I understand it, and I apologize if this is not true, but I heard it from somebody who was in a position to know, and it sounds plausible, was that at some point Google rediscovered that the first parts of news stories were more important for indexing than the later parts. And that's kind of a duh moment. I mean, they're written that way on purpose, of course, So
Yes.
then
Right.
the idea that a
Right.
bunch of engineers have to rediscover this after the fact was kind of, I thought, kind of funny. But anyway,
Yeah. Yeah.
typical.
Well, but
So
but it
yeah.
occurs to me though that it's and maybe this is why people study what you study, but so there's a shape to a story according to the journalism guy, according to the sports writer, but then that information somehow the context, the shape of the story, the all of that has to somehow be in some sort of frame that the actual goings on in that game sort of have to fit into. That's
Right.
that's maybe that's what computer scientists do. I don't know the answer to that, but it seems like the ideas of how do you know something is similar to something else? How do you know this is the same context or a different context from that? It's just,
Huge
and then
problem.
how do you express that in a way that is sort of that is easy to sort, that is sortable by a machine?
So this is really you touched on something that's pretty deep and kind of, I'll just say this. First of all, human beings do operate in context, and we're pretty good at recognizing the context in which we're operating and understanding what that means from the point of view of what we ought to be thinking about, what we ought to be attending to, what we ought to be, how we ought to be behaving and so forth. Um, that's a challenge for machines. Even I want to say something that machines are becoming more and more contextually savvy, and we can touch on machine learning and how that's and sort of large language models maybe in this context.
Mm-hmm.
They've certainly gotten much better at that, but this remains kind of a difficult challenge for computers. Now, people are not perfect at it either. I mean, people
Right.
sometimes misunderstand the context that they're in as well, obviously. So it's not like we're trying to emulate a perfect mechanism, but but the reality is that's quite difficult. And as an example of this, I mean, for a machine to understand that it has no idea what's going on is actually not an easy thing. You know what I'm saying? In other words, to build a system that understands the limits of its capabilities and understands when it should stop trying to do something is pretty challenging. And so, for example, in the self-driving cars that are currently being tested out in San Francisco, they do occasionally, when they start to get confused, I think they have this kind of model where, okay, just stop. And so the cars will literally stop kind of in the middle of the street, and they won't move any further until somebody comes and resets them, because they do have some sense that they become incredibly confused. But the only response that they have to that is, freeze. Basically,
Yeah.
that's the only thing the engineers could think of to do in that context.
Probably a good idea if it's a car, right? Yeah.
Well, yeah, you don't want it running into anybody for
No, right.
sure, So
Right.
it's been, that's definitely a big problem. Now,
Yeah.
this whole issue of context shows up in language a lot, because whenever you say something, it's in the context of the situation that you're operating in and the previous things that people have said within that context, right? And that's actually a big problem for all AI systems, to really understand what part of that, how big that context needs to be. This, for example, is a limitation of the current language models. They have a relatively limited context of text that they can actually use in terms of looking back to what was said earlier. How far back can they look, to be able to understand? Now, human beings don't necessarily, if you're reading a book and you were in chapter 12, you might not remember everything that happened in chapters 1 through 3, but you have some recollection of that, and you can refer back to that in the story. That's pretty difficult right now for AI systems, because we don't have a good model of context, and because the simple models of context that we do have aren't big enough. So there's a kind of a bizarre limitation right now in neural language models, which is how much memory did the computer, how big was the computer that you had to generate the model, and how much history can you afford to keep in generating that? And currently, right now in GPT, I think that the
GPT. Oh yeah, yeah, yeah.
which is OpenAI's. So there's basically a
Yeah.
number of companies that are doing research in this. Google actually pioneered a lot of the technology in this as a company. I mean, to be clear, neural networks, the renaissance of neural networks originally, anyway, to make a long story short, I think OpenAI's GPT can look back 4,096 tokens, and you can think of a token as a word, roughly speaking. That's how far back it can look. And it can't look any further back than that.
Look back where? Into what
in the text, in what was said previously in the text. Right.
Oh, okay. Okay.
Now you raise another question, which is, when we're understanding language, we're not. I mean, when you're reading a book, it's just the text, obviously. Yes. But when you're actually talking to somebody in the world, it's the situation you're in together, right? So
yeah. I was just thinking about as you know, one of the things I did for years was work in schools, and in I started one of the schools. I started a program for kids who were on the spectrum, and for those students, for those young people, context is enormously challenging. They'll do things that in another situation, well, right? I mean, if you go to a baseball game, it's absolutely appropriate to call out, go Jimmy, come on, get on base, whatever. But you're in a movie theater and you're watching something, and if you don't, right? I mean, you're so it's a
Just to make it clear, but the context that we were talking about in neural language models
yeah,
is literally how far back in the text can you look. So if you say to me, gee, that seems like an awfully simple model of context, how many words can you remember?
right.
I'd agree with you. It is a simple model of context. It's a good enough model of context to actually do some amazing things, but it's not. We're not done, is what I'm trying to say. I mean, there's
No, right. I get it.
a lot of work to
And
do.
yeah, plus, well, okay, so you mentioned GPT, so let's go there. I think Chat GPT, quite the buzz, um, and and as I understand it, and I tried it a little bit, or on some,
Everybody, I have to. We all
yeah,
have. Yeah.
that, and well, again, it's either the end of humankind or or why bother even learning anything? Everybody can do it. A machine can do it for you, and all that. And so we know neither of those is true. But so as I understand it, and from my experience of what I tried, is you can ask this program, this thing, to, hey, write me something, write me 3 paragraphs on Larry Birnbaum playing baseball, and for the Yankees
Yeah. Right.
in any year you pick, and it will generate some story based on a search of Larry Birnbaum, the Yankees, baseball, etc. Is this true?
Yeah. It can. Well, it can do that, and the question is, what does the result mean, or how good is the result, and that's going to depend on. I mean, I want to say a couple things. First of all, it's an absolutely amazing tour de force in technology. I mean, this whole the history of AI. I mean, one thing to say about this, first of all, is this has taken a long time. I
You
mean,
bet.
AI started in almost at the dawn of the computing era. Alan Turing, who's one of the founders of computer science, wrote
Mhm.
arguably the first paper on AI called, and he developed the so-called Turing test, which is, could you fool a person through a conversation into thinking that a computer was a person, roughly
Right.
speaking. And that paper was written, I think, in 1950 or published in 1950. And the earliest paper on neural networks really was published in the 1940s. AI really got going in the 50s through the 70s. There was and a lot of great work has been done all through that period, a variety of techniques. Uh, Neural networks got restarted again in the 1980s, actually at UCSD. And then eventually, a big center actually became the University of Toronto with Jeff Hinton and his group there. He had
Can,
been at
can,
UCSD.
can you define or tell us what neural networks are? I mean, I hear the
Sure.
term all the
So,
time,
so,
but I
so, I
don't.
mean, I guess I want to say a couple of things about
Yeah, yeah,
AI generally, which is that first of all, there are, as I said, a lot of different kinds of techniques that go into any given program that you look at and that you're interacting with. There's usually more than one method being used to solve the problem, right? And or different aspects of the problem will have different kinds of methods that are appropriate to them. So there are symbolic techniques that involve kind of abstract reasoning or logical reasoning. There are statistical techniques. Broadly speaking, there are going to be those two classes of techniques, either logical techniques or statistical techniques to actually model the world and to model kind of intelligent behavior. And the latter part would be called machine learning, although there are symbolic species of machine learning as well. And as I said, any given system that you look at is generally going to be mixing these up in a variety of ways. And I'll give an example of that in a second. Machine learning itself tends to fall into two broad classes. One is called supervised learning, and supervised learning means that there's a teacher, quote unquote, which might just be experience. It's some kind of a feedback that tells you, was this a good answer or not a good answer?
right.
Okay. So roughly speaking, the machine makes a guess like, is this a member of the category? It says yes, and it turns out to be wrong. and because it's labeled as being in a different category, and the machine will go like, oh, I made a mistake, and it will adjust its representation of the category appropriately to not make that mistake again in the future. Now, the issue with supervised learning is that you need training data that are labeled. In other words, where you can say, this is an orchid, this is a house cat, that's a microphone, things like that. So you have to actually label the data, and it can be very expensive to get labeled data because the labels typically come from human beings. Actually, the human beings are the people who know this stuff anyway and can label it. So, but that's a very important kind of learning for sure. The other kind of learning is called, strangely enough, unsupervised learning, when there is no teacher like that. And that would be, for example, clustering algorithms. So when you start to say, like, this thing looks a lot like this, like I have a bunch of data, and the data seem to fall into clusters, and I want to identify those clusters. And that doesn't need labels. It's just roughly speaking, you're looking for things that are close to each other and far away from everything else. That's kind of the definition of a cluster. And that's easier because although you need a lot of data still, you don't have to have a human being labeling the data or some kind of experience model labeling the data and telling you whether it was the right answer or not the right answer. So I'll take a pause there and say, there's a lot of different kinds of machine learning algorithms and a lot of different kinds of AI mechanisms. Neural networks are a particular kind, and again, they have their history at least 70 years old, or if not older. And they're basically a model that says we're going to start with a very simple component, which we'll call a neuron after the neurons in our brains. They're not really neurons, but they kind of modeling certain aspects of neurons. Right. And the neurons are going to be connected to each other through wires or at least software wires. They'll be connected to each other in a program or physically in a machine, and they will impact the computation of the neck of another neuron. So the idea is a neuron will sit here, and it will have a lot of input wires coming to it from neurons that are below it, let's say, okay? And each of those neurons below it is actually representing a feature of the situation that you're in. So for example, if you were doing computer vision, each of those little neurons literally might be a pixel in the camera that took the picture, okay? So you'll have in that case, you won't have just a line of neurons, you'll have a grid of neurons like this, right? And they'll be so that would be the original retina, so to speak, of the machine. And let's say we're talking about black and white. Each of those neurons will get an input value between 0, which is totally black, and 1, which is totally white. And then there'll be gray in between, let's say, we're only doing black and white. And so now we're going to put another neuron on top of that that's going to collect data from a bunch of neurons in the underlying retina, let's say. And it's going to compute some other feature based on the thing, underneath it, for example. So it might say, this thing looks like it's going to gather data from a region, and it's going to say, everything on this side of the region is kind of dark, and everything on this side of some line is white. So maybe there's a boundary here, for example. That's the kind of thing it would be computing. So you have these things wired up, and the way it does that is that these wires have weights on them, okay? So that the wires, the connections between the neurons can allow information to pass or not allow information to pass depending on the weight. And that tells you, roughly speaking, the kind of neuron that it's feeding into is deciding how important is the data from this lower level neuron to the decision I'm going to make. And you just keep cascading. And so deep networks are actually cascading these, layering them. So we start with the input data, then we have a layer of neurons that are taking those data, then we have a layer of neurons that are taking those, and then we have a layer of neurons that are taking those. And the idea is that you're going to eventually be computing higher and higher level features of the situation that you're in. So that's how they operate once they've learned. Now the question becomes, how do you set the weights on those connections? And that's where go.
Can I just ask quickly?
Sure, of course.
So is it the case, because all that sounds simple, but is it the case that you discover that even the simplest human event turns out to be incredibly complex in terms of how many sortings of importance you have to go through to understand something that is quite
So
simple.
you raise a big question, which is, so first of all, these algorithms do tend to be of kind of fixed length. And you're raising the point that sometimes we don't know how long we're going to have to compute before we get an answer. So these are typically very parallel kinds of algorithms. They're not sequential. And so they can't do everything. And you're pointing to some of the limitations. Is the principle simple? The answer is yes. It's amazing that they can do what they can do, given how simple the principle is. But the reality is that the machines that are built out of these simple mechanisms are absolutely gigantic. I mean, they're huge. They're enormous, and that's obviously where the power partly comes from, is that you have a lot of those things.
Mm-hmm.
So I didn't mention how do you learn the weights on these links between the neurons,
Yeah.
and that's really the kind of where the learning component of neural networks comes in, and the way that works is that let's go with the supervised learning case for a second. The machine will end up making a prediction at the very end. It'll say, like, I think this is David. I'm looking at this thing and I think it's David. And then the feedback will come back. No, that's actually not David. That's actually a triangle or something like that. And the machine will go, yeah, I made a mistake. That wasn't David. This output layer where I said this was David, it was not weighting its inputs properly. So I better change the weights on those inputs so that I don't say that this was David. Okay.
Right.
And each of those layers says, well, I made a mistake too. I have to propagate my error backwards. And so that's the way these systems work, is they propagate error backwards during learning. And then when they're functioning, they kind of move forward through the weights that got computed via that error propagation.
But the only
I want to say something right here. This is actually what I meant when I said this is not my area. I don't work on this. I mean, I know a little bit about it, but okay.
But can I just say that the element of supervision is only at that end over there.
Boy, that's a really, no kidding. It can take a long time to actually learn with a mechanism like this, and then it raises the question: how much is it like human learning, and in what circumstances is it like human learning? I mean, because there are some things that we learn very slowly,
Yes.
Maybe exactly how to hit the golf ball, or, take a lot of practice, but there's some things that we can learn, all at once right away, and we learn it and we never forget it. And, that's a very different kind of model of learning. So, again, I'm just, you're raising the point that as amazing as these machines are, and as amazing as what AI can do now is, there's a lot of things that we still don't understand about what's going to be involved in building,
One of the things that and maybe this is completely irrelevant to what you've just been saying, but it's sort of tweaked, it pushed the button. Push the button in this network right there. One of the things that I read about Chat GPT versus what's Microsoft was Tay, the one that was
the one that got withdrawn
was that GPT had much more human feedback in the training.
Did, yes. Mm-hmm.
And that Tay actually, I don't know if it had no human feedback or if it relied much more on the data that it was pointed at. So suddenly, if you apply it to Twitter, which is a hotbed of, it's a cesspool of ideas.
What did you call it?
A cesspool of ideas. It's like did
you say pool or cesspool?
Cesspool.
Yeah, right. Yeah,
yeah. That
the internet is filthy. No question about it.
Went right away to we hate Jews, and
of course,
because there's a lot of whereas something with a human being, depending upon who that human being is, correcting it would say no, we don't do that.
I remember early on when the internet was really first getting going and search engines were just getting going, we had in fact, Google had just been invented. It was still a Stanford University project, and we had a guy come from Stanford, pretty famous computer scientist, database guy, and he said, what we think we can do is use the internet as a measure of truth. Like we can just do a search for something, and if and count up the answers, and if more of them are on this side than that side, then that's probably the right answer. And we were like, yeah, I don't think that's going to be true. And we actually typed in the earth is flat. And you got actually at that time more hits for the earth is flat than for the earth is round. And there's a reason for that, which is that people who believe the earth is flat insist on asserting it all the time. Whereas people who believe the earth is round don't think they need to be claiming the earth is round. They're not fighting against science and society to make this assertion, right?
No,
So
you had one line in one of the, or maybe in a couple of the lectures that I took a look at. It was someone quoted someone who said something like, "Big data, the data speaks for itself,"
yeah.
and you made a very specific point that no, that's not actually true.
Yeah. I wouldn't do what I do. I mean, if I thought the data spoke for it themselves, I wouldn't be doing what I'm doing. I mean, I think that the data need interpretation, and I think that's really a pretty critical thing to me.
I think that's,
Yeah,
I mean,
that
I
having
don't know
it's
how
not.
it could
I
not
know.
be.
Look, I mean, the reality is you can do a lot more with less data interpretation than anybody would have expected if you have enough data. I mean, there's no gainsaying the incredible advances. Now, I want to say something about this, by the way. I still haven't talked about how neural networks get applied to, or deep learning gets applied to language. And I'll just say that very quickly.
Yeah, please.
All that these large language models that they're called LLMs or neural language models do, they have one task, which is to predict the next word. So what you do is you basically say, I need some milk. I'm going to go to the, what are you going to say?
Not cow. I'm going to go to the store.
I'm going to go to the store. Exactly.
Yeah.
Right. Okay. So it's an obvious prediction. And so what we want is for the machine to be able to make that prediction, given that
Yeah.
context,
Yeah.
predict the word store, or maybe the phrase grocery store or something like that. Okay.
Right.
Or maybe the name of a particular grocery store. So that's what you're going to predict. And they have this on your cell phone already, right? When you're trying to
Sure.
text people, it predicts,
Autocorrect. Absolutely.
or the thing that helps predict so that you don't have to actually type the whole word. It says maybe you want
Exactly.
to say
Yeah.
uh, tomorrow, or something like
Yeah.
that.
The thing
And
that
so
the
it's
thing that
gathering,
screws
it's
up my
gathering,
text messages all the time, right?
yeah, it's right. It's gathering statistics about the frequency with which certain words follow other sequences of words. Okay, and that's what these systems are doing.
Mm-hmm.
You take a neural network and you put it in a paradigm where it's going to take the n preceding words and proceed, and then be able to predict the next word. Okay, or actually, what it does is compute a probability distribution over all the words of the likelihood that that word is going to show up. Okay, and then when you take a thing like ChatGPT or any neural language model, when it's going to be used for the generation mode, that's why it's called a language model. It's a model of the statistical likelihood of words following other words in the language. Okay. Now, you might say to yourself, gee, there seems to be a lot more going on in language than just predicting the next word, and you'd probably be right. But it turns out that you can do a heck of a lot with this if you have a big enough memory and enough things. For
Mm-hmm.
one thing, it can memorize a lot of things, which is either good or bad. I mean, so for example, if you take these things and put in a passage from an incredibly common text like the King James Bible, it'll actually reproduce verbatim a lot of the next sentence or something like that, just because it's seen that so many times, right?
Mm-hmm.
And so that's what it's doing. It's predicting the next word, and that's kind of what it does. So you typically set up, if you interact with ChatGPT, you'll set it up and it'll predict the next. It'll kind of do that. Now, this is very expensive to compute. These models take millions and millions and millions of dollars of computing time to be able to get that. There aren't very many organizations that have that much data. It's an interesting artifact of our times. The internet was not built to provide a data store for AI to actually learn from, but it turned out to serve that role in part. So it's kind of, in other words, these are all texts that people put online for their own reasons
Mm-hmm.
and to communicate with other people. And yet now we have this incredible data store of stuff that we can use to actually train a computer. So that's that first of all was an exciting reality of online and online activity in the internet. But it's very expensive to compute these things. But it doesn't require any labeling. And the reason it doesn't require any labeling is because, and I'll tell you why, because
What
the
is
next
labeling?
word is
What
in
do you
this.
mean by
You
labeling?
don't need a human being to say, tell me whether this was the correct next word or not, because a human being already has told you that in the millions and millions and millions of sentences that you've seen
That you've just
where
looked
the
at.
word store followed a sentence that looked like that. Does that make
Yes.
sense?
Yes,
And
totally.
so that's kind of baked in already. That's what makes it feasible. So the thing is that you're right, that when you get a language model doing that, its output won't necessarily be uh, quite what you had in mind. And so what OpenAI did, which was kind of the next step, was to take the output from a language model like that. And again, to be clear, this technology was originally invented probably by a guy, I mean, in Hinton's group, by a guy named Yoshia Bengio at Toronto. And then eventually the kind of current um, uh, technical substrate was really at Google. A bunch of people did some advances, and then OpenAI picked that up and did that. I'm sure they're doing a lot of other things too, to be clear. I mean, I'm not trying to denigrate them. It's a lot of really smart people there.
Yeah.
But what they added, which was pretty smart, was to say, look, the thing we want to actually have some feedback to tell if this was a good answer or not a good answer, or a good continuation or not a good continuation. And so they did pay the money to get people to provide that feedback. And interestingly enough, what they did is they used that training to train another computer program to provide that feedback automatically so that they could amplify, because as much money as they paid to get people to answer these questions or make these evaluations, it still wasn't enough data. So they used that to train a computer that would then provide that feedback, which can be a little bit dangerous, but it worked in this case. I mean, worked very well. By the way, there's a little bit of controversy about how much money did OpenAI pay the people to do this work initially, and where were they paid? I mean, there's a certain reality to the internet right now, which is there's a thing called Mechanical Turk. I don't know if you've ever heard of it. It's a
I've heard
service.
this term, but I don't know what it is.
It's a service that Amazon offers where what you do is you have a question and you crowdsource the answer. And for example, you'll say to people like, what do you think this was a good, rate this answer from 1 to 5? Was it a good answer? Or rate this continuation from 1 to 5? And you'll pay them 1 penny or 5 cents each time they do that, right? So you distribute the work. So there's a kind of, you might call it knowledge piecework going on the internet right now, like the old days, sewing stuff at home kind of thing.
Yeah. Yeah.
And you can view this as a great boon and an opportunity for people who want to earn a little bit of extra money, working at home and maybe don't have other opportunities and kind of in their spare time, or you can view it as taking advantage of people,
Exploitive,
especially in
right?
countries
Yes,
where,
sure.
So it's a little bit of a complicated thing. But yeah, that's what OpenAI did. The results, I have to say, have been pretty amazing. Like, the thing does not always work, and it often says foolish things, and it says crazy things, and it says incorrect things. But the fact that it can say anything at all is kind of
Right.
staggering.
But it says things that everybody understands.
Yeah,
Enough to know that it's foolish or otherwise.
Yeah. I think, I will say this, that the people, I'm sure that there are people who worked on this who were sure it was going to work, but most of the people I've talked to who worked directly in this space were pretty surprised themselves that it worked as well as it did. I don't think they expected it to work as well as it does. So, and it's a mystery, frankly, why it does. I mean, the one thing to say about this also is these are really big big systems, and even though the individual components are very simple, the behavior comes from an interaction of a huge number of these things. And it's fair to say that we do not exactly understand why it works, which is a little bit scary sometimes. In other words, right?
That's actually what, man, maybe we're there, but that's actually what I wanted to ask you is, like, so we should be celebrating. And on the other hand, we should be a little bit, we should wake up in the middle of the night. So how should people who have no idea what you're talking about feel
I don't
about
know how I feel
investing?
about it, David. So you're asking,
there we go. That's the last question.
Look, what do I think? I think it's a great triumph. And I think, B, it is not the end of the line for AI. There's a lot of stuff that, again, we don't understand. So these machines, for example, there are certain fundamental things that they don't have, these kind of LLMs. They don't really have goals. When they're saying something to you, it's not because they want you to know something. I mean, they don't seem to go through the process that we go through in producing intentional or goal-directed behavior, right? People give them the goal, so to speak, through these prompts, right? Through these original setups, but they don't do that themselves. So actually, just to take an example in reading, I mean, when you are reading something, you're often, in some level, it's a very active process. You're asking yourself a lot of questions. Why did she do that? I mean, what does that mean? I mean, was it this or that? I mean, there's a lot you have, and you'll ask, and sometimes if it's a conversation, you'll ask a question, say like, I didn't understand. What were you trying to, did you mean this or something like that? And so these machines aren't active learners in that sense. They don't have questions that arise as they're trying to read because there's nothing that they want to know
Right.
except how to predict the next word. That's the only thing that they really want to know. Okay. And so again, it's kind of amazing that with that low level goal, you can actually generate the kind of behavior that they're generating, but it's not everything. So am I worried? No, I think it's a pretty amazing technology. I mean, I would love to talk more about the technology and its limitations, but we can jump to some of the social implications now if you want to.
No. Do a little bit more. Like what are some of the implications of the technology? I'm not sure I understand.
Well, I think first of all, I think, are there, look, even now science and our technology works in a very different fashion than this for the most part. People could look at that and get, worried that it's going to replace certain kinds of jobs. And the only thing I can say is that automation in general replaces certain kinds of jobs, and it has for the last 150 years, you know
Absolutely.
what I mean? And long before even computers.
Yeah, not a lot of work for horses these days.
Yeah, exactly. And in fact, the horse population of the United States peaked around. You can actually see peak horse. It's called. When were there the most horses in the U.S. and then the decline in the horse population because they weren't.
Because they didn't have any jobs for them.
Yeah, right. Exactly. So it's so I don't think that's going to. First of all, that's not going to happen to human beings because I don't think our purpose in this world is to have a job necessarily. So, I mean, without getting into too much detail, people are not animals and they deserve us. Well, people are animals. I mean, human beings are animals, but we're a certain kind of animal with a certain kind of rights by virtue of the kind of animal that
we certainly want that to be, yes. And
yeah, so I don't want to be. And by the way, I'm not trying to say that other kinds of animals don't have rights too.
No, I get it.
I'm just saying we have special rights, and I think most human beings would take that. And I don't even think that's
we're going to get letters from PETA, but whatever.
Yeah, I don't think that that's a statement of parochial. I'm not saying people should have special rights because I'm a person. I mean, I just think that given the difference between people and other kinds of animals, it seems apparent to me.
Plus, we made up the term rights.
So, well, yeah. I mean, anyway, no, I think this is a great triumph for technology, and I think computer technology generally has been just an amazing thing. Now, a lot of stuff has been being automated. I mean, even before, and we can decide whether we would have called it AI or not. I mean, do you think of a travel planning site as AI? Well, it kind of is. I mean, a lot of the work that went into that would be things like, again, route planning or scheduling. Again, those were AI problems 20 or 30 years ago or 40 years ago, and then they got solved, and we don't think of them as AI anymore.
Well, I mean, some of the stuff that so many people rely on, embrace every day. Like you pull up a song and the computer suggests to you a bunch of different songs, and damn it if it's not right about all sorts of things.
Yeah, absolutely right.
And you either run from that, or you celebrate. It's like, God, I never even heard of this artist. Fabulous, so cool.
Yeah, absolutely. I think it's a really so. For example, I guess what I'm trying to say is, did certain classes of work go away? Yes. I mean, there aren't as many secretaries in the world as there used to be.
Right.
Because of word processing instead of typewriters.
Right.
There aren't, or computers instead of filing systems. Okay. There aren't as many travel agents in the world as there used to be. Okay. Right. But, I don't think that's, but first of all, I mean, people are finding other work, and there are still travel agents. They do very high-end travel, and there are still executive secretaries, and they do all kinds of much more complicated kinds of work. And in general, I think, I think the elimination of certain classes of jobs isn't necessarily, a bad thing, especially, if it increases the wealth of the society overall. Now, there is a question
it took a
of,
lot. It took a lot to build the pyramids,
yeah,
but thank God for 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 earth movers.
yeah, I don't really want to do that for my,
No,
I mean,
exactly.
our ancestors did that. We don't want to do that. You know what I
Yeah,
mean? So yeah, absolutely. And I think that's a really, I mean, there is a question of how are we going to organize society?
that's
If this is true, then what's happening is that we're going to be able to basically produce more and more with fewer and fewer people, and
right.
the question becomes then how to distribute the fruits of this.
Sure.
Because the way it's distributed right now is everybody has a job and they make their money with
Right.
their livelihood comes from the work that they do. And if their work is less important, nevertheless, I mean, it's almost tautological. There's no point in producing all this stuff if nobody can buy it. You know what I'm
Right.
saying? So,
Right.
look, I think that those are real issues, and I think, but I'm confident that we're going to figure out a way to make it happen because, again, there's no point in doing this if it doesn't improve human life. I mean, what's
Yes.
the point actually? I
Right.
mean, so I think that I mean, I'm talking about from an economic aspect. I mean, there are
Sure.
scientific and technical challenges that are exciting to people who like that kind of challenge, but most people are not that interested in how it's getting done. They're just interested in
Hmm.
what it means, for them. So um, hopefully it'll end up meaning something positive for them. I think
Are there places where it is frequently the case in all sorts of disciplines that what's happening at the edges of those disciplines is probably the most interesting stuff. So is there stuff that's going on that's what are the now that they've quote solved this, what are they trying to solve now that
yeah. So the first thing to say is that we've made a tremendous amount of progress. We haven't really solved
yeah.
any of the problems that we touched on at the beginning about context and whatever. We've managed those problems, I would say, in a way that
Mhm.
yields useful technology. Um, uh, and I think there's something that I think would be an interesting timeline for people to consider. So let's look at self-driving cars. The original DARPA, so DARPA is the Defense Advanced Research Projects Agency of the Defense Department. DARPA has historically been the uh, funder and kind of, in some sense, um, instigator of a tremendous amount of computer technology and over not just AI, but a lot of computer science over the course of the last, since its founding in, I don't know, maybe around 1960s or something like that. So, for example, their biggest success probably was the internet. So DARPA used to be known as ARPA, and the internet used to be known as the ARPANET, okay, because it was built at the direction of and with the funding of and organized by DARPA. And so the entire internet as we know it actually came out of this research project that they had for building kind of robust computer networks. And there was a very famous, well, he's famous if you know who he is, but of course, this is a good example of nobody, if I asked you who invented the internet, you'd say, like, I have no idea. And actually, of course, a lot of people invented the internet. But if there's one person who could be said to have invented the internet, it's a guy named J.C.R. Licklider, who actually was a psychologist who went to DARPA in the 1960s and basically built that project and hired the people who ended up really building the internet. And he wrote a very famous paper in the 1960s called Computers as a Communication Device.
Mhm.
Okay. And the idea of computers as actually for doing what we're doing right now, as
Right.
opposed to computer crunching numbers. Okay.
Right.
Which was a revolutionary idea. You know what I mean? And so that's where the internet comes from. And from him and his colleagues and that whole project. And it took a long time. I mean, the internet was built originally in the 1960s as the ARPANET. Um, I think it was slowly went into a number of university computer science departments and computing centers and government labs. And so email existed very early on. I mean, if you were in a computer science department, you had email, you know, certainly by the 70s, if not earlier, but nobody else had email. So the only
Right.
people you could email would be other nerds, you know what I'm saying?
Right.
And I remember very vividly one day I got an email from my cousin. She's a linguist at McGill University in Montreal. And I remember thinking, oh, that's interesting. She has an email account now. I mean, and then at that moment, I mean, that shows you how dumb I was. At that moment, I realized everybody's going to have an email account. But until then, it never occurred to me that everybody was going to have an email account. You know what I'm saying? So it takes a long time. So let's look at the self-driving car thing.
Yeah.
DARPA conceived of something called the Grand Challenge, which was to build self-driving cars. The first Grand Challenge race was run around, I believe, in 2004, and it was run in, I don't know, the desert somewhere in California. It was run on a piece of road that had no other cars on it and no particularly complicated obstacles. And it was, I don't remember how long the course was. It was 10 miles long or something like that, or 5 miles long. And they ran that race in 2004. Not a single car got to the end of the road correctly. I mean, they all ran off the road or got stuck somehow before. So that was in 2004. Now, the thing to realize is that if the first Grand Challenge race was run in 2004, the project was probably conceived of at least 5 years earlier than that. So it's the late 1990s when DARPA thinks of doing this, and it wasn't just DARPA. Obviously, a lot of researchers said, hey, we should do this.
Right.
They ran the program, they gave out the money, and they ran this challenge. So in 2004, by 2011, we know that Google has self-driving cars driving around California. Okay. They revealed that they're cars being driven by a machine,
Yes.
that have no human drivers driving them. That's 2011. And so at that point, everybody thought like, oh, okay, they're around the corner. Okay. It's now 12 years later. Okay. And they're not actually quite.
And they're still not around the corner.
Yeah, they're still not quite there. You know what I mean? And so it's very important to keep in mind that the last mile is always the hardest. I mean, it's like so it took 7 years. It took, let's say, 12 years from when the project was first conceived in 1998, let's say, or 13 years, let's say, to 2011 when the cars were running, and only 7 years after the first race was run, to get to the level that we were at in 2011. And now it's the same amount of time since then or more, and they're still not quite working. You know what I mean? And I think if you talk to a roboticist, they would have said, well, duh, it's a really hard problem. You know what I mean? It's not going to be solved. There's a lot of specific things that go into it. It's not just one technical thing is going to solve this problem. It's just there's a lot of things that go on. I'm going to give you an example, which I hope will help the listeners to understand something about this. I had a chance to talk to some people who actually build self-driving cars a couple of years ago, and I was thinking, look, they use a lot of neural networks. They do a lot of machine learning. A lot of stuff is also built into the machines. It's not just machine learning. A lot of things are built in. A lot of things are learned. They're pretty complicated machines, and with a lot of different components operating according to very different kinds of principles. And I was trying to understand kind of how much is learned and how much is built in. And so I thought for a while, and I came up with the following example, which I'll now tell you about, that I thought would be a good diagnostic to help me understand this. And so here's the driving situation. You're in the middle lane of a 3-lane road in your direction, and you have to turn right in a little while because Google tells you, or your mapping system is telling you that you have to turn right in a little while. Before you turn right, you need to get into the right lane, okay? And the question is that driving behavior that you need to get into the right lane before you turn right, is that learned or built in self-driving cars? So I'm asking you just for your intuition. What do you think?
I would say it's built in.
It is built in. You're absolutely right. Now, when I ask people, even sophisticated people, I would say at least half the people I ask will say it's learned, because they assume that they assume that a machine learning system actually. And the reason that they think that is because if this rule is built in, there are 10 or 20,000 other things like that are also built in, right? And that seems like a pretty complicated thing all of a sudden. It's not a neural network just learning how to do this. It's like excuse my expression, a shit ton of stuff in there to actually make it go
Yeah.
beyond the machine learning component. And people are always kind of surprised. Many people are very surprised to hear that. Many actually technically sophisticated people are surprised. So you gave the right answer. It's built in, but it's that actually tells us something about kind of the state of technology. It's not just so if you say, well, ChatGPT has solved natural language processing. No, it hasn't. Is it a big advance? Absolutely. But no, by itself, it hasn't solved it.
Well, so let me tell you the wrong thinking of why I gave my answer.
Okay.
It's like, it would seem like that would be so important for that rule to be in place that I wouldn't want to risk it learning it or not. Or because I never want somebody going from the middle lane off to the right.
Yeah. No, you're absolutely right. Now, a couple of things to say about this. First of all, okay, even if it were learned, it would not be learned through experience. In other words, we wouldn't put a car on the road, have it get into accident after accident, and say like, "Oh yeah, I guess I should get in the right lane." So obviously, this would have to be done in a simulator. That's the first point. It could not be done in the real world if it were going to be learned.
Right.
And that's actually a really interesting point. But there's a lot of things that we don't learn by experience. We don't learn not to go through a red light by experience. It's not like we go through a red light, have an accident, go through a red light, have an accident. Hey, maybe we shouldn't go through that weird light over there. Maybe we shouldn't go through it when the intersection when that light is red. What's that light doing there? I don't know, but we shouldn't go through it.
I wonder why it's red.
Yeah, or I wonder why it's there. Why is there that light? Nobody goes to an intersection and says, why is there a light there? You know what I mean? You know what the purpose of the light is. So that's a good example of the difference between right now how machines are learning about these things and how we're learning about these things. Okay, and that's actually very important because you asked the question, should we be afraid of this? Right now these machines are doing some pretty amazing things, and I've done a little bit to make them amazing. But to be honest with you, I mean, I've contributed my part, but this has been a huge effort by a lot of people, a lot of very smart people, and over like I said, over 60, 70 years now that this has been going on, and now we're finally seeing some of the fruits of that, which is amazing. The first thing I want to say is it's a very exciting time to be an AI person, you know what I mean? Because a lot of stuff that we've been working on for so long, things are finally beginning to work, and that's a pretty exciting time. But, it's clear that specifically neural networks don't understand the world the way that human beings understand the world. They don't see the world the way you and I see the world, okay? And that can be seen very clearly in the kinds of mistakes that they make, which are inhuman mistakes. Okay, they make mistakes. They make. So let me give you an example. I mean, there's some pretty. You can find this on the internet. There's some pretty famous examples that are pretty obvious. For example, you can construct images where you and I will look at the image, and what we see is static. We see like snow on the color television set in the old days. Just a bunch of random colored pixels. Okay, and the machine will say, "Oh, that's a robin." It'll look at that set of pixels, which is hash, it's noise as far as we can tell, and it'll say, oh, that's a robin. Okay, so it sees something that's not there. Okay, the flip side of that is you can take a stop sign and alter it by changing some pixels or putting some stickers on it, and the machine will say, oh, it says speed limit 45. Okay, no human being would make those mistakes. No human being would look at the hash and say it's a robin. No human being would look at the stop sign with a few pixels changed and say, "Oh, it says speed limit 45." All right. So it's a category of error that we don't make, and it shows that the machines don't see the world the way that we see the world. Now, the flip side of that is that we make mistakes that the machines don't make. Okay, like we do a lot of things in decision making, for example, based on the most recent information. That's a common preference that people have is to overweight recent information.
Yes, right.
And for certain kinds of decisions, of course, that's the right thing to do. And probably, to be clear, in the environment in which we human beings evolved, it most likely was the right thing to do. But in the world that we live in now, it's not always the right thing to do. Absolutely. And so we tend to make these kinds of decision-making errors that machines will not make. Okay, and so to me, this opens up a super exciting possibility, which is of collaborative human and artificial intelligence. And not just to me, I should say, this is a theme that a lot of people are now working on, because it's an exciting idea. The idea that people have strengths that the machines don't have. The machines have strengths that we don't have. Um, they make mistakes that we don't make. We make mistakes that they don't make. Maybe working together, we can actually do something that neither the human being nor the machine by itself could do. So that, yeah.
Can I ask you,
Sure.
because it sparked something. So do you know of? I mean, are there things that have been learned in the exploration of artificial intelligence that broadly that have shed light on how human beings think,
I
how
think
human
so,
beings
yeah.
process information? That's
Look, this was one of the key. So, I mean, there obviously there is the technical an engineering challenge of the field, which is to build machines that are smarter and smarter. But there has always been this kind of psychological or cognitive science component as well. No question about it that the people who founded the field, and many of the people who work in the field today, not everybody, but a significant number of the people who work in the field, are still very interested in what light does this shed absolutely on the human mind and how
mm-hmm,
human minds function, and
mm-hmm,
I think that's been a really and to be clear, the ways in which AI succeeds and fails, and the ways in which it is similar to and different from human intelligence, I think are all providing that kind of insight into, into how we operate. And I think that that's absolutely been that was always a goal of the field,
yeah,
for
that's
sure.
interesting. It also is, that example about the snow looking like a robin to the
Yeah,
computer,
yeah,
and the computer and us not knowing what the computer is doing. It would be like, I want to know, what is it about that
right,
picture that the computer sees as a robin,
right.
because maybe there's something there.
Yeah, so that's actually especially in light of the rise of neural networks, which are these huge models, as I said,
Yeah,
and not necessarily very well understood.
yeah,
That does raise a lot of concerns that people have, which is, why should I take a decision based on something the machine said if I don't understand why it said it? You know what I mean, or why that's a good recommendation. And so this has given rise to a whole kind of thrust in AI called explainable AI, which is that the machine should be able to somehow
mm,
explain its reasoning to you so that you can at least get some sense of whether this is actually correct or sensible, or ways in
mm-hmm,
which it's not correct or not sensible. And that's a huge area of research right now. Absolutely.
yeah. Oh, that's interesting. That's super interesting.
Yeah.
So are there things that keep you up all night that have to do with this?
No, I mean, I'm not worried about computers taking over the world. I don't think that they have the same. I mean, right now they don't have that kind of goal structure. I don't think that they. I guess people are worried about the idea that they might take a goal and kind of do something obsessive with it that turns out to be detrimental to human
Yes,
beings.
that's
I mean, that in
the
some sense
that's
was
what the movies are about, right? All the
that
movies.
was the theme of 2001 of Kubrick's
Sure.
2001.
How?
Absolutely,
Yeah.
was
Yeah.
the machine wasn't exactly malevolent. It's just it was confused in some sense,
Yeah.
right? I mean,
Right.
and so it therefore made a bunch of mistakes, which included killing people, right? So I mean,
Right.
uh, so yeah, I mean, I'm not that worried about that actually. I don't think I don't worry about I don't worry about Terminator kinds
Yes. Right.
of kinds of scenarios very
Right.
much. I think that I think that yeah, I don't worry about that much. Look, I
Yeah.
think the future is going to be pretty strange. Um, in fact, the present is already pretty
The,
strange, to be honest with you.
the
And I think that
president, the president gets really strange really fast.
yeah, I mean, so this is actually this was an idea that of course, began to become clear, I think, starting as long ago as really the 50s, that the rate, so I don't know if we should go here, but I'm going to go here anyway, that
Go
the
there.
rate of change of
Hmm.
cultural change and scientific knowledge and kind of economic change and so on was increasing. It wasn't just a question of things are changing fast. they're changing faster and faster. The rate of change is accelerating all the time, right?
Hmm.
So it looks like this. You get these kind of exponential changes, which is where the term singularity comes from, by the way. It comes from the idea of this exponential kind of rise to infinity, so to speak,
Hmm.
that it starts going up so quickly that, and the, there was a, I think there is a concern, and I think I feel this way myself, that things are changing so fast that it's hard for human beings to keep their bearings or their footing. That you get it's easy to get confused. It's easy to feel unanchored. To feel unsettled. People are to some extent creatures of habit, and there are things that we're comfortable with, and as those things start to change, okay, but if they change very quickly, I mean, when you and I were kids, there were like 3 billion people on the planet,
Right.
right? There are now 8 billion people on the planet.
Right.
That's like more than twice as many people as when we were kids, which is like crazy. You know what I mean? I mean, that's a pretty crazy thing, and that, so even there, right away, there's a rate of change thing that was kind of astounding. I mean, there were 1 billion people on the planet in 1800. So between 1800 and 1960 or so, we got from 1 billion to 3 billion, and since 1960, so that was 160 years to get from 1 billion to 3 billion. And then it took another 60 years to get from 3 billion to 8 billion. You know what I'm saying? Which is like, but that's what
Yeah.
exponentials look like. You know what I'm
Sure.
saying? And so
Exactly.
things are changing
Exactly.
very quickly, and it's easy to get confused. There are a couple of things coming up on the horizon that I think are going to change things very dramatically. And the only thing I can say is I try not to worry about them because I don't think there's anything to be done. You know what I mean? It's just these things are going to happen, um, I apologize if this is annoying to people or upsetting to any of the listeners. But let's take the genetic engineering of human beings.
Hmm.
You know, is it a good idea to genetically engineer human beings? I don't know. Is it going to happen? Of course, it's going to happen. I mean, I don't care if you pass laws against it or don't pass laws against it. There are going to be countries that are going to do it, or there are going to be people who will decide to break that law. And some of it, initially, of course, it will be very benign. This child would be born with a genetic disease that we can now prevent by genetically engineering them. They'll be exactly as they would have been, but they won't have
Right. They
some
won't have
horrible
this
disease.
thing.
And why would you not do that? Of course you will
No,
do that.
absolutely.
And the next thing will be like, well, I don't know, we could make her smarter. We could make her taller. We could make him faster. You know what I mean? And we could make them live longer. And so all of that stuff is going to happen. I don't see a way to prevent it. So first of all, the genetic engineering of human beings. I mean, I'm not trying to change the subject from AI. I'm just
No, no,
saying
no. Go
there's a
there.
series
Let's
of
go
things
there.
coming up which are going to happen that are really going to change society quite dramatically, maybe even more dramatically that's already been changed. Genetic engineering of human beings is one of them. Life extension technology. So right now, we are living longer and longer. I mean, thank God you and I are pretty healthy and vigorous still. I mean, as they say.
Yeah.
Um, and I mean, historically people didn't live that long and weren't that vigorous as long as we are now, and that's due to modern nutrition and modern medicine. And
Hmm.
there's a lot of
Hygiene
things,
in general.
So,
Yeah.
my dad died last year. He was 100 years old. And I think that's becoming more and more common. I think nowadays, if we have someone who we know and love who dies at 60 or 65, we go, well, that's young.
Yeah.
Even if they die at 75, we might go, well, that's pretty young.
Yeah.
And we feel a little sad about that. So there will be life extension technology that's going to be developed of a variety of kinds, and we will live longer and longer. And the third thing was artificial intelligence, and the capabilities of machine. And the fourth thing is going to be direct brain machine connections, which people are working on as
Which are,
well. So
people have been working on for quite a while. And
that's
yeah.
exactly right. So are we
Yeah.
there yet? The answer is no.
No.
But we're
Right.
making progress on all four of these things, and they
Yeah.
will get better and better. And if you ask me, should they be done? I can't answer that question. Will they be done? Yes, they will be done. You know, I mean, it's almost the case that anything that can be done is going to be done. It's at
Yeah.
some level. I mean, should we have built the nuclear bomb? I don't know, but It could be built, therefore it was built, and so these things are going to happen, and they're really going to change very fundamentally, I think, about what it's going to mean to be a human being. I mean, I didn't used to believe this. I used to think, this whole idea of the singularity of a change in human consciousness. I used to think it was complete bullshit. You know, like one of the people who's associated with this idea is this guy Ray Kurzweil.
Sure. Yeah.
Ray
Read a bunch of his
Kurzweil
stuff.
He built a lot of interesting machines in his life. He built the first really functioning, good OCR system for reading books. So the Kurzweil reading machine was really the first thing where you could scan a book and it would actually say, oh, that's the letter H or that's the letter F or something like that. And so you could take text and not just take a picture of the text, but actually identify the letters and put them in as letters in a file, right? And so that was really a pretty interesting technology. He developed that. I don't remember when. That might have been the 70s or 80s even when that got built. Kurzweil's at Google now, and he's a big believer that, that people are going to live, maybe forever or essentially forever. But the point is that things are really going to change a lot. And I used to think that it was nonsense, that this idea of the singularity was, complete nonsense. But I don't think so anymore. I think it is going to change who we are. And I think that's going to be complicated and interesting. I mean, the value structure of a human being who lives for 1,000 years is not the value structure of you and me. I mean, they're going to have different values and different goals than we have. And
I mean, I'm chuckling only because this is true. I remember reading in the LA Times when the Dalai Lama turned 80. It was a big article. It was big, right on that. I forget what section it was, but it was the whole first page. Below the fold, there was a little, 2 lines about the oldest woman, the oldest woman on the planet, having just turned 115. I think she's obviously since passed away, but it occurred to me then, it was like, could you imagine walking up to the Dalai Lama on his 80th birthday and it's like, so what are you going to do for the next 35 years?
Right.
That's a long time.
Or what if it's the next 135 years?
Exactly. What if it's that?
So let me ask you, and we're really far field, so you should feel free to
I'm not,
edit this out.
This is the point of Curiosity Invited, because you get to places that, who knew?
So let me ask you a question. Do you want to live forever?
Yes, absolutely.
You do? Really?
Oh, I'm the person that, I am that person that when people are like, they put microchips in the vaccines, it's like, I'm the guy who's like, sign me up.
Bring it on. Yeah.
Yeah. Come on.
Yeah.
Like,
where's that chip? Okay.
Yes. Yeah.
Okay. Well, so you do want to live forever. That's interesting. I would be curious to know how many of our listeners would want to live forever.
Yeah.
I think younger people.
It depends what living. I mean, if I'm just, do I get to
you look pretty vigorous and
them,
happy, so I get you're doing stuff,
Yeah.
And I feel I'm still getting up in the morning and doing interesting things. So,
yeah.
But if you ask me, do I want to live, do I want another 1,000 years of this? I don't know if the answer is yes. I think when you're 25 or 30, the answer is clearly yes, of course, But when you're in your 60s, I don't know that the answer is, I want to live another 1,000 years, another 1,000 years.
No, I want to find out how it turns out, man.
Okay, well, that's awesome, actually. Good for you. I mean, I think it's going to take a special. Look, one thing I'm going to say, it's going to take a special kind of person to take that decision. By the way, Not everybody's going to say, "Yeah, absolutely, I do want to live to be 1,000." So there's that. Then there's the question, by the way, of whether the rest of the world is going to let that happen, because in a world in which children are dying of actually malnutrition is less frequent now. In a world in which let's put it this way, in a world in which people have to watch their children die from preventable diseases, they're not going to be that excited about the idea that somewhere else in the world people are living to be 1,000 years old.
Yes, exactly.
And they're going to do something about that lack of excitement.
And that's why, and that's the challenge that it's not a technical challenge, but it is a incredibly complex challenge that people have to deal with. I have a friend who was, I don't think he is any longer the head of it, but oh, what's the fellow's name? The junk bond guy. Uh,
Milken?
Milken. So Milken had, he's got the Milken Foundation and Milken Institute, and he had a center for the future of aging because people are. I mean, we're already at the point where more and more people are living longer and longer, and
Correct.
it's it's going to have an impact on everything.
Sure.
And so it will have I mean, and as people live longer and longer, and I think you're right, people will live longer and longer. People will come up with ways for that to happen, and unless we figure those kinds of questions out, and we are gonna. Well, it'll be a. If we don't figure those questions out, I think what you just said was right. Is that those people on the other side of the earth who are watching their children suffer from diseases that are preventable while those people are living longer and longer are going to do something about it.
And actually, I think they would be right to do something about it. If I were
Absolutely.
them, I would do something about it
You
too,
bet.
right?
You bet. So
So
it's
yeah, so we're going to live in a world. So that's going to be a challenge. I mean, there are going to be smaller challenges. So, for example, I have a job where I don't necessarily have to retire, and I love my job. I love doing what I do.
yeah,
I enjoy teaching. I love the research I do. I love the projects I'm involved in. And I feel like I'm still making a contribution. I'm not interested in retiring right now. You know, on the other hand, I could look at the situation as a young person and say, get the fuck out of the way. I
yeah.
mean,
Come
really,
on.
I mean, you're taking up
What
a
am I
slot
supposed
for
to
me,
do? Yeah,
Yeah, exactly. So
exactly.
I think that's a whole series of things too. Now we can overstate that. I mean,
Sure.
I think that the percentage of Americans who are uh, past retire, the percentage of Americans who are over 65 who are still working is
Still
actually
working.
pretty low. It's actually like 20% or something
Yeah,
like that, or something. I mean, I might
yeah.
have that wrong. It
I
might be
think it's because
40.
most people really hate their jobs.
Well, and they also have tough jobs. I mean, people have very physically demanding jobs, for
Yeah,
example, which are really you can't keep up and which are actually detrimental to your health after a while.
you
So I
bet.
mean, I think that there's very again, we're living in I mean, I'm a very I've had a very privileged life in a lot of ways. So and I understand that. But yeah, so I mean, I think there's a lot of social challenges that are going to come up. I mean, I think I have you were saying the future of aging. I think that's an issue. I think especially for example, in a world in which the birth rate is dropping, which, given that we are now at 8 billion people, is not a bad thing. But of course, there are places where it's been dropping a little bit too quickly.
Yeah,
So those places include China, Japan,
Japan.
a
Yeah.
lot of Europe,
Hmm.
not all of Europe, but a lot of Europe.
Hmm.
And the problem that this leads to, of course, is that you have a smaller and smaller percentage of the population is working age and is actually carrying the load of supporting everybody else, and that becomes a challenge in all of
Hmm.
these countries.
Hmm.
But that includes things like caretakers. I mean, so right now, but this is an example of a thing like how great a job is that? So my dad, when he got pretty old, he had people to help him out, and they were very loving people. By the way, they were very caring people and very loving people, and he, amazingly enough, did not need full time help until the very end of his life.
Hmm.
He just needed somebody to kind of cook and clean and kind of help him get dressed and take a shower and stuff like that. So he was pretty he was pretty healthy and but where are the people who are going to do those jobs? So, for example, the Japanese government actually, in particular, has a pretty big initiative in robots, in robotics for elderly care, right? And that's also an issue in the United States because we're looking towards the future when there will be people who are old who are not able to take care of themselves that well. That's going to happen too, and there'll be more and more of those as well. And how do we build a society in which they can be taken care of?
Hmm.
Because I mean, again, they're human beings, and they need to be treated with some respect and have a life that's not,
Indeed.
horrible,
Indeed.
right? So it's uh, there's that. There's also the future of work, which you touched on earlier. What are we going to do if the machines are so capable? Um, I have a slide that I sometimes use at the end of my talks. It's entitled "The Future of Work" is the title of the slide, and then on the slide is a picture of a bunch of tall glasses of beer of varying colors. It's like a dark beer, less dark, all the way to a kind of an IPA or something like. So we have very light beers, very dark beers, and kind of the whole. We have maybe it's 8 beers on the thing, and so I call that the future of work. And I guess it's a joke. I mean, what I don't mean is that we're all going to go to the bar and have a drink. That's the future of work. What I mean is, if the picture is intended to evoke a craft brewery, right? And when you go to a craft brewery, what are you buying? Are you buying beer when you go to a craft brewery? So
Yeah.
what the people at the craft brewery are selling is they're not selling beer, they're selling an experience, right?
Yes.
And they're
Yeah.
selling a relationship. Like the people who made the beer will be there and you can talk to them about what kind of yeast fell
Just
into this
exactly
beer.
how many hops, what kind of hops were those?
Absolutely. And
Yeah.
so they've done something very interesting, which is they've decommodified their labor. I mean, beer was originally a craft thing, and then with the rise of industrialization, it
Yeah.
became a commodity. And now they're decommodifying their labor into something that's a craft, and where what you buy from them is not just the product of their work, but your relationship with them, and the fact that it's local, and the fact that it's interesting and unique,
Yes.
and so that starts to raise the question. And so that's also happened in artisanal food, of course, or local food
Mm-hmm.
is another area where that's happened. And then we can ask the question, what are the other parts of our current patterns of consumption where we could go back to craft instead of mass production,
Right.
and be happier with the result and have a relationship with the people who made this for us instead of just getting it off the shelf, and it was made in a factory in Singapore or something like that, and well, actually, Singapore's too wealthy. They don't. I mean, Vietnam, I guess. Anyway.
I think actually people would be heartened when people will be heartened when a person who's working in the world of computer science is thinking about these things. So
Look,
thank you.
everybody. I mean, I mean, so look, at different stages in your life, you think about different things. Most of the people, and by the way, especially young people now in the field, are very concerned with these questions of equity, questions of social impact, of doing something good with this technology. I mean, it's kind of amazing to see, really. I mean, my students are much more motivated by these concerns than I was at their age, for sure. I mean, so it's very,
Mm-hmm.
it's kind of a big thing in computer science now,
Mm-hmm.
and I think in almost all
Yeah, sweeping the
aspect,
world.
anything in college that people are doing. I mean, they're asking the question, what does this mean for society? How can we make the world a better
Right.
place? And how does
Right.
what I'm going to do here contribute to that? I think
Yeah, I
that's
mean, and that question, which I think I come out the same way as you. I think if it can be done, it probably will be done. But people will ask the question, and people do ask the question. We can do this. Should we? And
so. I guess what I want to turn that into is, how do we do this in a way that's
yeah,
ethical? How do we do it with integrity? How do we do it in a way that helps people? Not. I think. Again, I find it difficult. I don't understand. I'm not sure how, if it's possible to do it, we'll be able to stop from doing it. I don't know what the mechanism would be for that. I think when it comes to AI, absolutely, this is a concern that people in AI have. There's a difference between having that concern and being able to do something about it,
right,
unfortunately. Like,
right,
what can I actually do? I will say this, that right now, the ethical practice of AI has to do with the ethics are in the minds of the AI engineers and AI scientists. In other words, the injunction is on us as human beings to build our technology in a manner that's ethical. I think it is the nature of AI, and hasn't yet been much discussion of this. I think that eventually the machines are going to have that be part of that discussion. In other words, right now we have the ethical principles and we build them into the machines. The machines don't think about ethics when they're doing what they do.
mm-hmm.
But I think eventually they will. I think eventually we're going to have to build ethical models into computers, and have them reason and think about those ethical models as they, as they make decisions, to think about, the ethical implications of the decisions they're taking, and whether, yeah.
And that, I mean, this may be a good. I'm looking at your time. I'm looking at the time in your life, but that may be the perfect place to stop. It's the that's both the hope and the source of all of those science fiction, nightmares, is that the machines realize that the human beings are actually violating the ethical principles that maybe we have set or maybe they have set.
Right.
And
Yeah.
and
So I want to say two things about that. One is, of course, you're alluding to Asimov's three laws of robotics, perhaps. Isaac Asimov, the science fiction writer,
yeah,
had these three laws of robotics, which is, I think, don't permit harm to come to yourself. I forget. And then it was, don't permit through action or inaction harm to come to a human being. It was the highest one, I think, too.
right.
Uh, uh, there. The second thing is, actually, speaking of, the ethical principles, is that, again, this again is apocryphal, but it makes sense to me, which is that when Google first had the self-driving cars in California, of course, they did get into accidents, and not major ones. I
No,
mean,
right.
it's not
Right.
like, there have been, of course, some terrible accidents involving self-driving cars where people have been killed.
Yes. Yes.
One, of course, a number where people have foolishly believed the marketing campaigns of some of the, or at least the implicit marketing campaigns, even if not the explicit marketing materials of some of these companies that sell this technology, and have, literally been watching a movie or reading a book instead of driving the car,
Hmm.
and gotten killed that way. But there was one particularly tragic one in, I think, Phoenix, Arizona, several years ago, where a pedestrian was carrying a bicycle across the street, and the car, if the guy had been riding the bicycle or walking without the bicycle, this might not have happened, but it got confused by the fact that it was a person carrying a bicycle, and it didn't stop, and it hit this guy and killed him. And I think that was the first known example of a pedestrian being killed. So that's very tragic. But the most common accident, um, is actually getting rear-ended at a stop sign, because the self-driving cars will come to a complete and full stop at a stop sign, and a lot of people, of course, will expect will be coming to a rolling stop, and will expect the person in front of them to be doing the same, right? And when it isn't a person and it comes to a complete stop, the self-driving car gets rear-ended. So this apparently is a pretty common. This was a pretty common species of accident initially. I Yeah, we can. I guess it's time to come to a stop. I mean, I think, the thing about it is, if the machine has ethical principles, like, what are these machines lacking right now? They have this incredible model of language. Sometimes, to the extent that the language is mirroring the world, they have a model of the world. They can actually use this to generate all kinds of amazingly interesting and fluent language about all kinds of things. They can solve problems. They're kind of innumerate, right? They have a hard time with arithmetic, strangely enough.
Really?
Yeah, absolutely. Yeah, they have a hard time with logical. It's very strange, but yeah, anything that involves explicit symbol manipulation is actually not that easy. Um, just like it's hard for people to learn how to do, it's been hard to get machines to do that. They don't. And when you think about it, it's pretty complicated. And the big problem they have with, and this, by the way, there's a lovely New Yorker article on ChatGPT, which basically has this nice analogy, like it's a blurry JPEG of the whole internet, and it's worth reading. But the author of that article makes the point, and I think this is a well-known thing in the field, that, for example, in doing addition, the hard thing is learning how to carry. Like, carrying is actually the complicated thing in addition.
Hmm.
Like, adding up the columns of numbers is not a big deal, but
Right.
realizing that you need to carry the 10 or the 2 or whatever over to
Yes.
the next column
Right.
is actually kind of a complicated
Hmm.
thing, and they don't really understand that very well. So I don't know where I was going with this. All I'm trying to say is they have this capability, these predictive capabilities, based on, their model of the language. To the extent that the language mirrors the world, they have interesting quote unquote knowledge of the world and a model of the world, and they can use it to solve problems to some extent. What don't they have? They don't have goals, and they don't have ethical principles. And I guess what I'm suggesting is that as we build more and more complete models of AI that are more competent, they will have to
They
have
will
goals,
need to have goals.
and they will need ethical principles. And so, at that point, of course, they will be becoming more and more like human beings, I
Yes,
think,
indeed.
under that model. So that's, I guess,
Yeah.
maybe that's the place to stop. I don't know. You tell me, David.
No, I think that is, and I am being sensitive to your time, and so Larry Birnbaum, thank you so much for being
David,
willing
thanks
to
for the
talk to
opportunity.
somebody.
This was a hell of a lot of fun. I really
This was
appreciated
really
the
fun.
opportunity. Yeah.
Yeah, me too, me too. I really am grateful.